As we start, before I even start at all, I want to hear some of the cool things. If, in fact, Becky, would you mind running a mic for me? If you heard something particularly cool at your table, or you saw something cool, you're like, more people need to know about this, or you heard something cool, raise your hand and let us know. Share a couple of them with us. I like setting the mood here.
Well, my most exciting thing that I've seen and heard about, actually seen, is the new baby at the zoo.
Oh, I haven't even heard about this. What baby is baby elephant?
I saw her when she was, I think she was 2 weeks old, because my daughter works at the zoo, and she hadn't been open to the public, the greater public yet, so that was really fun.
That's really cool. New baby elephant at the zoo. Great. Somebody else. What else did we hear that was cool? What did we read about, see in the last year that was really cool? Yeah. Here, she's going to bring you a microphone.
Okay, I'm going to tell Elijah's story. So he just read a book called Sapiens, right? And so what differentiates Homo sapiens from whatever.
Okay.
But anyway, the differentiation is we tell stories. I thought you would love
Oh,
that.
That's so cool.
We're the only species that tell stories. Is that right, Elijah? Did you want to say something else?
We're the only species that tells stories. That's really, really awesome. What a cool thing to read. Thank you. Yeah, isn't it? That's really cool. What else? What else we hear? Let's go over there.
I read something earlier in the year about the Nebraska Mid-Continent Rift.
Ooh.
And this is some 1.1 billion years ago, the North American continent nearly split in two, leaving behind a 1,200-mile swath of volcanic rocks known as the Mid-Continent Rift that may be able to produce enough natural hydrogen to yield vast amounts of clean energy.
Hey, wow, that's cool.
But not under the current regime.
That taps in a little bit to one of the things I shared, which is not my coolest thing, was my second coolest thing. You'll hear my coolest one later. But I've read and been fascinated all year by the developments in nuclear fusion, which are going to largely be dependent on hydrogen. But the way that can change the world, and I think it was this last month we had in France or something like that, the longest sustained reaction yet. So we're getting really close to that incredibly clean energy, which is super cool. Anyone else have something else cool that they read this year? Yeah, let's go back to Sandy, and then I'll get us actually started.
I was going to have Bill do it because I don't know what the planets were, but 2 nights ago, and it's been going on in February, you can see the planets. He's got it.
Oh, I've heard about this. Yeah.
Yes, but there were 3 of them in line, and it was so big, and they were so close together that night. You could, it looked like a giant plus mark with all kinds of lights that it was there forever. I mean, it was the biggest thing. Nobody could have missed it.
Yeah, so, really cool.
Very fascinating.
Yeah.
He's got no. Okay, it's an app.
Okay.
Called Skyview, and anybody can put that in there or get it from their store.
Cool.
And it goes through all of them, and you can see them every night of different types.
That's awesome. I love it. Thank you. I think we also have a lunar eclipse coming up next week too. Wednesday night, I believe. That's going to be cool. Lunar eclipse. We'll be able to all see it. That'll be sweet. Thank you, everybody. Thanks for starting off with that. The theme of today's class is wonder. So I wanted to start off with the things that brought out a sense of wonder in us in the last year, so we all get into that headspace together. To begin, I want to start for the final time with my disclaimers for this class. If you haven't attended yet, I want to make sure everyone knows this. Disclaimer number 1 is I am not a science teacher, much less a quantum physicist. I don't know what I'm talking about. There are some people here in the room that know better than me. There are some scientists, and we're glad to have you. Thanks for coming. And we'll make sure you have time to offer things as well, because you can contribute some things to these that I just can't, because I am not a science teacher or a quantum physicist. Number 2 is this is not a class where science proves God is real. That's not the goal of this class. If you go out and you Google search Something like quantum faith, you're going to come up with a lot of books that say how science proves the existence of a God, or books that try to take religion and superimpose it onto science in a dominant way. That's not what we're doing here today. Disclaimer number 3 is correlation does not equal causation. This is very, very important disclaimer, because in this class we have danced that line very delicately. We toe the line of correlation and causation often, but just because two things are correlated does not mean that they cause one another, and yet they can make us go, and is my goal of this whole class, because opens up doors in our minds to experience new things that we haven't considered before. So, to start off, I'm going to, once again, let someone else explain something better than I can. This is a short clip of a video from a talk by an artist, local artist named Scott Erickson, who's an amazing artist and speaker, and he's going to talk a little bit about wonder and set the scene for the lens that we're going to use for the rest of our lesson today.
My wife and I met and were married in Seattle, and then after a few years I got offered a job, an artist in residency in Houston, Texas. And when somebody wants to pay you money to make art, you say yes. And so we packed up all of our stuff and we moved to Houston. We made the move a bit of a road trip and a sightseeing trip. And the first place we stopped was in Idaho. It's a place called Craters of the Moon National Park. I'd never heard of it, but thousands of years ago this volcano exploded. There's lava rock everywhere. There's not a lot of vegetation, so it looks like the surface of the moon, like astronauts train there sometimes. It's also one of the least light-polluted places in North America. And so when we were checking in, the ranger was like, hey, it's clear tonight, and the stars are amazing here because there's no light pollution, so you should try to stay up and see the stars. We're like, yeah, we will. And then we were setting up our tent. People would literally walk by and like, hey, make sure you stay up and see the stars. They're amazing. Like, okay, we will. Thank you so much. So we did stay up with a couple of bottles of wine. And by midnight, we were like, stars are awesome. I've seen them, gonna go to bed. Okay, we're like, cool, stars. No, we go to bed, and then sometime in the middle of the night, I feel this nudge in the sleeping bag. My wife's like, I have to pee. And I was like, yeah, I do too. We'll go together. The bathrooms are just down the trail, so we get our stuff on, and we unzip the tent, and we step out, and it was this! Not as pixelated, but it was this! And I was filled. Look, I've grown up my whole life in cities where there's a standard 16 stars out every night. This is what the night sky looks like when you live but there's no light. And I was filled with wonder. I mean, and pee. I was like, oh my gosh, it's so amazing. I'll be right back. I gotta go. Just don't go away. Right? And we went to the bathroom and then we stayed out for a bit together and just like looked at the immensity and beauty of it all. What is the common denominator between the stars and the ocean, the surfing, the nature, the concert? The common denominator is you. The common denominator is you. Because wonder is not an external destination. Wonder is an interior filter that you can learn to look at life through. It's most easily accessible to us in new situations because we don't have a narrative about it. After college, I had this experience where a friend of mine backpacked in Europe for a while, and we bought these train passes. We could hop train to train, town to town. And we had this experience where we'd get off the train and we'd be like, oh my gosh, this is the most beautiful city I've ever seen in my life. And then 2 days later, we'd be like, I'm so bored. Maybe later there's another more beautiful city I'll ever see in my life. Like, what happened? Did the city change? No, we got familiar with it. And familiarity is what kills wonder. Familiarity kills wonder. Familiarity is a very helpful tool. I have kids old enough to have sleepovers and stuff, and it takes forever for them to go to bed. But finally they do. They're sleeping out in the living room. We turn off all the lights, and then we're like, oh, I forgot something in the kitchen. I don't want to turn on the lights and wake them up, but I know how to navigate my living room in the dark without stepping my toe, because I'm familiar with my living room, right? Like, that's when it's helpful. Familiarity is not helpful when you've been married a long time and you get bored with your spouse. Familiarity is not helpful when you're in your life, your body, every single day, and you're like, it never can be different. It's always going to be this way. Nothing can ever change. So we should go to concerts, and you should go look at the stars, and you should try surfing once in your life. But like, we also have jobs and responsibilities tomorrow, and I was like, I know it's a little cliche, but I was like, is there like some kind of like wonder hack that I can figure out? Is there like some kind of wonder hack I can do every day to kind of get in touch with this filter? And I started practicing something, and it works. I do it every day. I did it before I started this, and I want to teach it to you. But before we see what that is, we need to look at some art to understand what's happening to us. So this is an artist named Scott Listfield. He's a good follow on Instagram, and he has this series of paintings of this astronaut walking around a vacant world. I don't think it's post-apocalyptic. Like, this is just what Los Angeles looks like on a good day. But it's like, it's a world where there's no other people. And so we're following this astronaut, this visitor around the world. And we're seeing all these things that were left, these kind of artifacts, these remnants. And we're like, yeah, what are these things? Who built these things? Who are these for? Who went there? What are these things? What is this place from Southern California that promises joy inside of you, right? And when we begin to unknow what we think we know, the doorway of wonder begins to open in us, because unknowing is a doorway to wonder. So the practice I want to give to you is, if you can, every day for a little bit, just try to become a visitor to your own life. Try to become like an astronaut of wonder. Now, I was going to do a whole campaign with like hats and shirts and buttons and stuff, but then I found out that astronaut of wonder is the same name as the orgy tent at Burning Man, and I was like, I don't know. I feel like there's going to be a lot of Google searches like, whoa, that's not what I was looking at. Sure, I'll sign up for the newsletter. Yeah. So, just between us, we're all astronauts of wonder. But as astronauts of wonder, we have this tool, and that tool is a question. And here's the question. The question is, what don't I know? What don't I know? Seriously, like, this helps me the most when I get really, like, low or depressed, because often the narrative that's informing that is like, you can't get out of this, nothing can change. And so just go, well, what don't I know about what's happening right now? Like, what don't I know about what's happening right now? Even like right now, what don't we know about what is happening right now? There's like cameras and you're all here watching some guy most of you have never heard of, just a friend brought me, there's stuff happening, but what don't we know what about this room? There's some great art in here and stuff, but what are things that are in this room we wouldn't know about? Like what if when this room was being made, one of the construction workers came, and the night before, he broke up with his girlfriend. He didn't break it up, it failed, the love of his life, the relationship failed, and he came to work heartbroken. And as he's like up on that wall finishing it up, the great muse, the great poet came upon him, and he just all of a sudden pulled out his work pen, and he began penning the greatest love poem that's ever been written by a human being, greater than Rilke or Rumi or all the R's. And he just wrote this great, beautiful poem, and it's covered up by plaster and paint over there. Probably not, but you don't know. What if behind here is a trap door to an underground tunnel, to an underground water slide, to an underground lake with a pirate ship in it, like in the movie Goonies? Probably not, but you don't know. There's so many hidden things around us. How about you? Inside all of you right now is a heart that's beating that you're not in charge of. Like all of us are here right now because of something we are not in charge of. And if you spend 30 seconds on that thought, it will fill you with wonder.
He's great. He's really great. By the way, this is not a paid ad, but we're going to have some art from him on display throughout the season of Lent in here. So if you want, he's got art and meditations and things like that. And if you're interested in seeing this entire talk sometime, I'm thinking about throwing together an event where we watch it all together. He's really excellent. He was actually he was my preaching professor in college. He taught me how to preach. Just an amazing speaker, amazing artist, amazing guy, and he's local. Wonder. In the first week of this class, we talked about the breakdown. This idea that the last 100 years especially, in the realm of science and the realm of theology parallel, we have had this incredible movement of unknowing, of realizing how much we don't know. That's torn down the sense of familiarity and opened us up to a whole lot of possibilities for wonder. I want to follow, for the rest of this class today, a little bit of his formula so that we can get in touch with this sense of wonder a little deeper. And since we're talking about science, I want to start with one of the forces that is probably the most familiar force in the world to us. We're going to talk about gravity. We all know gravity, right? Things go up, things come down, always. It's the law. That's how it always works. Over the centuries, different theories about gravity have existed, and they've evolved pretty significantly. Aristotle's theory of gravity was really interesting. He believed that objects had a natural place and that it was the tendency of all objects to go toward their natural place. So there were earthly objects, which obviously their natural place would be earth or somewhere deep within the earth, so they were pulled in. They were pulled in toward the earth. But then there were some other objects which must have been different. They must have had a heavenly natural place, such as fire. And fire goes up. So he said there's some sort of origin, there's some sort of sense of belonging for everything in existence, and that is what takes you to your place. And he said, well, and this sounds so redundant with our modern language. Part of this was like, well, heavier objects, they fall faster than lighter ones. Well, duh. It sounds ridiculous to think in our brain. So this was a completely different understanding of how gravity might work way before we got to what is a modern understanding. And then if we fast forward like 1,300 years, an apple falls on the head of Sir Isaac Newton. And he realizes, oh, this happens a lot. Must not be the first apple he's had conk him. I don't know. He says gravity is some sort of force that pulls objects towards one another. So rather than the objects being pulled towards a place that is a natural place, as Aristotle would say, Newton says gravity is actually two things pulling on one another. And in fact, we are all, and everything is all pulling on each other, always. And the strength of gravity then, according to Newton, was that the mass between the two objects and the distance between the two objects affected how strong the pull is. The things with bigger mass, planets, suns, they pull really strong. And then there's also people, like we have gravity between all of us right now, and that is a very weak pull, according to his theory. Also, the distance between objects happens. Somehow gravity dissipates over space. It lessens the further you get away from the object with the highest mass, according to Newton's theory of gravity. This was groundbreaking because it explained planetary orbits and falling objects using the same universal law. It took the small things that we see here, things that we thought were small things that we see here, and explained also the biggest things that we see in the universe, and seemed to unify it all together under one theory where everything made sense. In fact, we probably still think of gravity mostly through this lens. When you think about gravity, who thinks about it as a pulling force, where the earth is pulling me down? Yeah. Sorta. That's more Newton than our real understanding of gravity. But it's a helpful idea that sticks in our head, and for a long time, very predictably, pretty good. Did a really good job predicting how things would work in the universe. It did a pretty good job mathematically. And then Einstein comes along, and he says that gravity isn't a force, it's not a pull, but he says it's instead the bending of space and time, or space-time, the combination of the two, which is the fabric of the universe, by mass. One illustration that's commonly used is like if you think about putting a bowling ball on a trampoline, how the trampoline would bow, the fabric would bow around the bowling ball. That mass interacts with space-time, the fabric of the universe, somehow like that, like it actually bends it when it comes into contact with it. Similarly, more mass bends more than less mass. And this kind of makes sense, but not really. Other people will explain it as then if we are traveling through curved space-time, it could kind of be like if you're going around a corner in a car and you get pulled outward by the force. If you get poured toward the door, yeah, if you're going through a curve, you would feel a force pulling you one way or another. Another famous thought experiment that Albert Einstein used is he equated an elevator going up really fast, that sinking feeling you would have pushing you into the floor if you were in an elevator going up. He says that's the exact same as gravity. And that doesn't mean that we are moving down, it means the elevator is moving up. The space is moving, and we are within it feeling the forces of that movement, of that curvature. It's a totally different way to think about things. Now, this has done a lot that Newton's theory of gravity couldn't do. It predicted things like black holes, gravitational waves, and light bending around stars. It shows and we can look out on the map, there are maps of the universe now that are made entirely by seeing how light bends around objects with great mass. And by and large, they are very, very accurate to the math of the theory of gravity Einstein produced and with the theory of general relativity. It's a game-changing theory. However, there are a couple things we don't know about gravity. Which, that seems pretty comprehensive, right? It feels like we should have a good understanding. And if you had walked into this room this morning and someone was like, hey, what's gravity? You feel like you'd be able to answer that pretty confidently? Yeah, maybe. Here's what we don't know. What is gravity? We do not know what the nature of gravity is. What we do know is that it works. We know that it happens. We know that it's really predictable. We have math that demonstrates that proves how predictable the outcomes are. And this can go out into the universe. We can apply it to the universe, looking at things, guessing how much mass should be there, how much force should be pulling, and the math is pretty good. But we don't know actually what makes it happen. Another thing we don't know is why is gravity so weak? There are other fundamental forces. There's the electromagnetism, there's the strong and the weak nuclear forces, and gravity is so much weaker than those other three forces. And we don't know why it's so much weaker. It takes a mass, think about if you were to set a paperclip on the ground, you have the entire gravity of the planet pulling it downward. If you took the smallest magnet and put it above it, that would zap it right up. It would overpower that gravitational force instantly. Gravity is a really, really weak force, and we don't really understand why it is that way. Another thing interesting about gravity, it being one of those four fundamental forces of the universe, it's different than the other three because the other three have what we call quantum explanations. In other words, we can look in at when we see the force of electromagnetism happening, we can look in and we can see on a quantum scale how the particles are interacting with one another and making that force happen. Electromagnetism is the easiest example of this. We know about protons and neutrons in the nucleus of an atom. They have a positive charge. We know about that we have the electrons with negative charge. Those balance each other out, holds everything together. There's a pulling force between them that binds things. We know about electromagnetism. There's also the strong and the weak nuclear forces, which hold together the nucleus of the atom, which is a strong force, and then the weak force, which repels sometimes particles from within the nucleus of an atom. And they all, if we look down at the closest pieces, we can see exactly the particles, the things that are happening to make those happen. They have a quantum explanation, but gravity doesn't. We don't have that answer yet. There has been theorized a particle that is called a graviton, which would be one of those subatomic particles, something that would, at the smallest scale, be enacting the force of gravity physically. But we have not been able to find it. It's been created mathematically. The properties of it have been guessed, have been estimated. But with every experiment that has been attempted over the last 70 years, there has been no trace of finding this particle. Now, part of it could be gravity is such a weak force that we just scientifically, we don't have equipment sensitive enough to find the smallest particle that would be so small and so it would interact so weakly with the things around it because it's such a weak force overall that it would take something so incredibly sensitive to detect that. That's what some people theorize is an issue that's keeping us from finding the graviton. The other answer is it may not exist. We don't know. It's a theory. But we don't have a quantum explanation for gravity like we do these other fundamental forces of the universe. That is really strange. Another thing that comes up as we talk about gravity and what we don't know is can general relativity, Einstein's ideas, and quantum mechanics be unified? I think it was in week one of this class we talked about Einstein did not like quantum mechanics. He was not a fan. He did not like the seemingly probabilistic nature of it. He did not like how uncertain it all felt. And part of the problem was it doesn't mesh well with his theory of gravity affecting the space-time of the universe. Until we have some sort of explanation of how gravity, the force, what's the actual mechanism behind the force of gravity, these two theories which govern our understanding of the entirety of our universe on the smallest to the biggest cosmological scale, they're not unified. They're not connected, and they do stand in some places at odds with one another until we find these answers. So I don't know if you've ever heard someone just like say it, like, oh, why do we need, I don't know, whatever. Say, why do we need religion? We know everything. We got it all figured out. This is not a class that proves science. That's disclaimer number 2. This is not a class where science proves God, not a class where religion tries to take dominion of science. And at the same time, recognizing that statements like that, we are not there. We're not close to that place. We have a massive rift in the middle of the 2 leading theories that decide, or that describe the nature of our physical universe to us. Another question that comes about with gravity is, how is the universe held together? Because gravity holds our universe together, right? And I talked about, we can map out the cosmos by seeing how light is bending through and looking at, we're really good at looking out at distant planets and saying, okay, we know how far away you are, so we know about how big you are, and we can even calculate their general density, so we can say, okay, this planet has about this much mass. Then we can look at the whole galaxy and we can say, all the planets within it have this much mass, and the suns have this much. And so we can calculate, plug that into the math equation, and we can say, this is how much gravity should be generated. And these galaxies are out there spinning through space. They're spinning. Now, if you know anything about spinning, when you spin, there's a force also that propels you outwards, right? It's either centripetal or centrifugal force, depending on where you're located within the spinning. I know that. But it's this force that propels you outward. I get those 2 mixed up all the time. It's what? Which one? Centrifugal. It's centrifugal force in this case. Not center seek. So it's centrifugal force because it's the one pulling you away from the center. Thanks, Tom. See? Disclaimer number 1. Keep that in mind. So there's this force that's felt by us when we go around a corner in a car, and that planets within galaxies feel as they spin out in space. And what we've learned, because we're really, really good at math, is that force, that spinning force that should be throwing everything out, should be way stronger than the amount of gravity that should be present in each one of those galaxies. That every single one of them, based on everything we can see and calculate how much mass should be there, every single one of those galaxies should be flinging their planets and stars off into space, because that centrifugal force should be more powerful. But it doesn't. We should be hurtling away from the Milky Way based on the centrifugal force that's there and the mass that is in the Milky Way to keep us here. But we don't. Why? The answer is, we don't really know. But we're going to talk about one of the things we think we might know. And this is where I get into a place of wonder. Dark matter. We're going to talk about dark matter a little bit. Dark matter is invisible mass. It's this theoretical invisible mass. It's an unknown substance that doesn't emit, absorb, or reflect light, which makes it totally invisible. I just talked about the math discrepancy. Based upon this math discrepancy that we see within our universes, within our galaxies, they believe that dark matter has to be about 80% of the mass in the universe in order to generate enough gravitational pull to balance those forces out. 80%. What we know is that dark matter doesn't interact with light, doesn't emit, absorb, or reflect light, but it does interact with gravity. In fact, so far, gravity is the only thing that we see it interacting with. We can detect the likely existence of dark matter through its gravitational pull on galaxies, which keeps them holding together. We also can plug it in and it fixes our math problems. But once again, we've looked for many decades now for a quantum explanation for any particle, for any example that shows that this concretely exists, experimental evidence. It doesn't exist. We haven't found any of that. Now, this could be our own limitations, but as it is right now, it is generally widely believed that dark matter does in fact exist, that it does make up 80% of our universe, and we can't prove it. We can't. We don't have proof. It fixes the math consistently. There are maps of the galaxy that have come out recently in like the last 3 years even that say they're mapping out where dark matter is spaced in the universe because they can see actually where the gravitational bend of it is bending light. So something has to be bending the light. Some sort of mass has to be generating a gravitational pull. Something is affecting the universe. Something's holding us all together. We can't see it. We can't prove it. We just know it has to be there. It has to be there. There's kind of a counterpart to dark matter, which is known as dark energy. And dark energy is probably an even more mysterious force, which causes the universe to expand at an accelerating rate. I'm probably going to butcher this, but basically, since the Big Bang, the universe has been expanding. And it's not just expanding directionally like we think of it. It is everywhere is expanding in every direction at all times. So when that happens, if you think about you have this much space and everything expands, now you have this much space. Where did the new space come from? What makes new space? Some sort of energy, some sort of force that relates to the vacuum of space exists that is accelerating, expanding the actual space of the universe. They estimate that this makes up about 68% of the energy in the universe, which is way more than normal matter and dark matter, and just the physical space of the universe, in fact. We really don't know. There's a variety of theories of what this could be, a cosmological constant relating to the energy that is in the empty space. We talked in week 1 about empty space does weird things. Particles sometimes just appear there and disappear. We don't know where they come from. We don't know where they go. There's a lot we don't know about space. But this is some sort of unknown force of nature. It makes up 68% of our universe, and it is the expanding. So what we have here, somehow, something we can't see, something that we can't prove, that despite our best efforts we've been unable to test, holds our entire universe together and constantly creates newness in the universe. Wonder. Familiarity kills wonder. Like we learned last week, we talked about the intuitive sense that we have about the way the world works. And we understand that there are great forces of probability that govern our physical universe, and we use this to move through our lives all the time. This is normal, this is natural, this is good. It helps us to be able to do this. And yet, we are constantly learning that our world is so much more than what we think it is. He uses an example, I think, in that clip about navigating the kitchen in the dark. You're familiar with your kitchen, so you can get around. Well, quantum physics makes us even wonder about that. It makes us ask the question, and this is an example of hyperbole, but is our furniture even there in the darkness until we stub our toe on it, right? The unknowing that is presented by this, the deeper we dig, it's amazing. Which is this unknowing as a doorway to wonder. The more we learn, the less that we know, or at very least, the more that we are realizing we don't know. And that in and of itself is wonderful. This has been the dominant story of both science and theology throughout their entire histories, and it has been incredibly amplified in the last 100 years. The very basis of religion and faith, I think, is seeking to draw closer to a force that exceeds our ability to comprehend it and our tools by which to measure it. It's a mystery, and it is wondrous. When we gain new glimpses into the mystery, our views also must change and grow and evolve. This isn't being less faithful either, as people have sometimes billed it to be, but instead it is more faithful. It is becoming more accurately in touch with the divine force in the universe. I want to give some examples. Some times when scientific discoveries have fueled new theologies. We've touched on a couple of these throughout the class. If we go back, most of in the last 500 years. So if we go back to heliocentrism, the idea that the sun is at the center of our galaxy or of our solar system, and we are spinning around it, and the new cosmology, the new image of how planets and solar systems all work then in that idea, that was a major shift, and it initially was thought to contradict some parts of the Bible, the idea that we were flat and then there was a firmament and God was right up, God was up. But instead, we saw over time theology started to evolve to this and started to realize that maybe biblical descriptions of the cosmos were theoretical or metaphorical rather than literal. They're not meant to be taken literally. They had a different purpose. So our theology about the cosmos, about heaven, when we think heaven, we still point up, right? We do still do this. This is like something within us, and yet every single one of us knows, like, that's not there. There's a metaphor to the upness of heaven, and that's a theological evolution that has come about as a result of a scientific discovery. Germ theory, a couple hundred years ago, really started to become a thing, and we started to see, maybe sickness, illness isn't divine punishment. Maybe God isn't just striking people down. In fact, maybe God isn't the sole author of healing either. Maybe prayer, maybe laying on of hands, maybe that isn't the only thing we can do to heal people anymore. But now we have medicine that starts to evolve as a result of germ theory, and we start to see that theologically as a means of God provision and God's healing. And on top of that, we as human beings, we have a new theological agency to heal one another, to take care of one another as a gift that was given to us from God. That's another example. We talked a lot about evolution, so I won't go into this too deeply, but I think just last week we talked about evolution bringing up some significant questions in Christians about what is our nature and our purpose, and how special are we if God didn't just mold us out of the sand and breathe life directly into us like the story says. How does that change the way that we think about who we are in relation to God? Instead, we start to see theologies involve in maybe evolution is actually a mechanism. Maybe when people say, how did God create? Well, those stories then, once again, become stories of metaphor, stories of deeper meanings in the Bible, and we start to see evolution as, well, this is how God created. This is the mechanism that God used to bring life into existence for all creatures, not just ourselves. We see the Big Bang Theory come about. To some people, very scary, because it seems to contradict, and God spoke and said there would be light, right? But instead, we've seen even like popes have come out and said, no, this actually reinforces the idea of divine creation, that there is a physical expression in the Big Bang of the ultimate divine power. Think about trying to wrap our heads around a singularity that contains all of the matter and energy in the universe and yet takes up no space and then explodes with such forces to create everything. If that doesn't sound divine, what might? But that is a theological evolution that's come about from a scientific discovery. Quantum mechanics, even in the last 100 years, has made us ask a lot of questions. One of the natures of quantum mechanics that we've talked about is how they are so probability focused, and how there is something that happens where things aren't concrete yet until there's some sort of interaction with them. That's one of our interpretations of it, but it opens these questions of that probability is a force that drives the universe, which makes it a lot harder to think that the universe is predetermined, that everything is going to go one specific way no matter what, because we see at the fabric of it, it's not like that. It might be most likely to go one certain way, and then sometimes it doesn't, which enters into us a whole new entire way to think about our human agency. We are co-creators of the universe. That quantum mechanics tells us that we are co-creators with free will that God gave us to build the universe with God. We affect it in real, tangible ways. That's a significant theological development. There's even newer stuff that's happening right now. I want to talk to you about my real coolest thing I've read about. This is in the last 2 weeks. If you haven't read about this yet, get ready. This is so cool. Microsoft came out with a new, I'm going to butcher the name, but Majorana 1 chip. This is a quantum computing chip. And basically the story, now this may be Microsoft propaganda because most of the stuff about it is coming from them, but here's what they're saying, which is really cool. Basically, years ago, as quantum computing developed, Microsoft saw that the direction most companies were taking had a ceiling to it. That it would happen faster, but that it wouldn't be able to go as far. So they as a company said, we're actually going to try to explore some different directions and come up with something that won't happen as quickly. We won't be the initial pioneers of quantum computing, but we will actually be able to create something that is more sustainable, that is more scalable, and that can be the future of commercial quantum computing. If you don't know what quantum computing is, how do I do quantum computing in 10 seconds? Computers, classical computers that we know of are run on bits of information. Each bit can be a 0 or a 1. It's binary language. Quantum computers, instead of using individual bits that are zeros or 1, they use entangled particles in what are called qubits. So these quantumly entangled particles, because they exist in superposition, they can be like Schrodinger's cat, dead and alive at the same time. They can be 0 and 1 at the same time. And then because they're entangled and because the communication between entangled particles happens seemingly instantly, what happens is this opens up so many more options that quantum computers can process information massively faster than classical computers can. For example, I believe Google came out with one this year, a quantum computer, that solved a problem that was so complex, it would have taken the strongest classical computer in existence literally the amount of time that the universe has existed to solve that problem. And Google's computer solved it in about 10 minutes. So that happened. And then this is bigger. Microsoft's new chip, they invented what's called a topological superconductor. It's a new material that is not, it is a different state of matter. It is neither solid, liquid, nor gas. And they use this topological superconductor to contain each individual qubit and to connect them together. And what it has done is it has increased the stability, the accuracy of the information that's coming from the qubits, makes them communicate with one another faster, and the biggest thing is it makes the scalability of qubits in a quantum computer massively higher. So instead of the traditional route, there's a limit to how many qubits can go in, but in this new way that Microsoft is using, they say that this is scalable to 1 million qubits on a single chip. This would be, now this hasn't been created yet, this computer with 1 million qubits. That would be an amazing undertaking, but they say it's possible now. And if that was created, that computer would be more powerful than every other computer on Earth combined, working together. It's insane. It's wonderful. It's amazing. The way they are talking about this theoretical computer that can now exist is that it could go and create self-repairing building materials for roads or airplane wings or your phone screens. It could create earth-saving compounds, solutions to carbon in the air, solutions to creating biological catalysts that can break down every single type of microplastic and turn it into usable byproducts. They're talking about creating life-saving medicines via enzymes. You would ask this. This is the AI that would come from this level of power would be as simple as, they say this in their article describing it, any company who ever invents something for the rest of the world would need only ask. And the computer would tell them how to build it right the first time. Trial and error, development, experimentation. This computer would be so capable of understanding the nature of the universe through the lens of quantum mechanics that it could just tell you the answer. It's amazing. Elijah, yeah, what you got?
It definitely sounds like Microsoft propaganda.
It sounds like Microsoft propaganda. It might be. But what has happened is amazing to think about. It also opens us up to the need that we do have for theology that's coming around this. Imagine if this existed and our understanding of the world, the possibilities that exist, exploded that rapidly. Theologically, we are going to have some responses that have to happen. We are going to have to adapt, grow, change to think about that. There's a branch of this called digital theology that is already asking some of these questions. One of the questions that's come up regarding AI a lot is, what makes a person? Can AI have a soul? Think about the sci-fi narrative that you've seen where someone can put their intelligence, their self into a computer, some sort of robot, some sort of device to sustain them longer than their physical body could live. According to Christianity, is that a person? Does that still need salvation? Can you transfer the soul? These are questions that we have to ask, that we have to think about. At what point does AI become smart enough that it gains? We're gonna have question and discussion after this, but I know it's popping up all the questions. At what point Does AI become so smart that we think of it as a person? Does that exist? What constitutes a soul? Is it intelligence? Is it consciousness? Is it self-awareness? We have all those things, but what if our computers got it? What would differentiate us? These are theological questions. How should Christians utilize AI and technology? Man, this is going to be really important. This is going to be so important. We already deal with a little bit of it, the AI ethics. Is it everything is theft, right? How do we use AI responsibly? Not plagiarizing, not stealing people's work. But as it goes and this world opens up, there's going to be potential for problems that exist, world hunger, things that exist in the world could be solved by the doors that this is going to open, or it could make some people really, really rich. It could make some people really, really rich. How do Christians see using, when ability explodes and expands like this, how do we need to respond out of our values? Another one that people are talking about right now is, in what ways is virtual reality different than in real life for faithful communities? We deal with this a little bit with Zoom, right? We're talking about how is going to church on Zoom the same as going to church in person? But what if church became something you could put on your goggles and it's like you're there, but you're sitting in your living room, right? And you could see the other people there with you, their avatars or whatever, in a virtual reality, virtual church. What about a virtual Eucharist? What is the difference? We have to ask these questions. Some of them we've seen creep up in little ways. Zoom church, the pandemic actually did some of this, right? Zoom church, or like communion. Can you bless communion over the phone? Like, what does it? Can it be blessed through Zoom? All this type of stuff. But these are questions that in the digital era will continue to have to be asked of, like, what is distinctly different? What is the substance of us? What is the substance of our community? Can that transfer? Or what needs to be clung to and protected at all costs? These are deep theological questions that are going to emerge in this next era, and this is coming fast because what they say with this modular on a chip, and again, probably Microsoft propaganda, that this computer with 1 million qubits, rather than being decades away, is now years away, thanks to this breakthrough. Now it's your turn. We're going to close with a discussion, and then we'll hear a little bit about it. And this is a silly exercise, but I actually have 3 prompts for you I'm going to read. And I want you to, in your tables, think a little bit about how theology might need to react or respond in 3 hypothetical scenarios. So here's what we got. How might our Christian theology need to change if we learned that there are, in fact, parallel universes to ours in other dimensions? Or how might Christian theology need to change if we learned that the sun will explode and destroy the earth in exactly 273 years? How would our theology need to change? Or that a new, more evolved earthly life form is emerging that will overtake the dominance of humans on earth? How would our theology, just spitball, have some fun, think about what might that tear at, what might that pull at in our faiths and our beliefs and what we think about ourselves and what we think about who God is and how God relates to us, and what kind of new questions, what kind of new thoughts might we need to think if one of these hypothetical scenarios were to come about. We're going to take 5 minutes or so. Don't go crazy, and if your table hones in on one, pick one and just hone in on it and enjoy it. And then we'll close, and I want to hear some of the fun stuff, and then we'll let anyone else share thoughts or questions they have as we close. All right, take 5 minutes, enjoy this, have some fun. Yes, I want to hear a little excerpt about what happened out there. Like, can we start here at this middle table? They said they're having too much fun. Who wants to share with us a little bit about the fun, the silliness you had exploring one of these questions?
Well, so we were focusing more on number 2,
Yeah.
and then we took a little.
That's good.
Lean into number 3, but we were talking about how 273 is a long enough time away that it may as well be eternity. Like, it's too long for us to envision. It's like we can't think like that's past us, that's past our children, that's past our grandchildren and our great grandchildren. That's like at least 4 generations. So it's like, okay, And so we were sort of like, what I think the funniest thing we were laughing about was the idea that we have to start immediately a campaign to remind people that no one knows the hour or the day of Christ's coming, and we are going to, and you cannot rely on that number.
Good. I'm glad that my chime of 273 years worked.
It's good. It's a good number.
Because that actually exists, what you just talked about, right?
Yeah.
Like, we know the universe physically has an end date on it.
Yeah.
Like, that will come. But it's not this close, but it still feels about that far.
Yeah.
That's interesting.
Yeah, well, and then it made us start asking about, like, we have to ask ourselves, who are we responsible for, but also who are we responsible to? And those are the kind of dilemmas we're going to have to start getting people to think about. Like, why should we care about what's going to happen 273 years from now? Like, and who asks us to care? So that's kind of where we were going, and then talking a little bit about the new, more evolved earthly life form is reminding ourselves that we are not the be all and end all of creation. Like, yeah, maybe we might have been in the book of Genesis the last thing created, but that was the last thing on that day. And then, of course, what happens after Sunday is another week. As everyone who has been to Earth Camp knows, I sing that song. On the 8th day, God made more bugs.
Yep. Yeah.
So, yeah.
Love it. Thank you. Thank you. What else? Another table. What else came up in your silly conversations? Go back to Tom.
So we talked about various things. One was we looked at all three of the questions, and they're all constrained to either time or space or energy or matter. So they're all physical nature and time related. And so we're thinking that God is spirit. So I don't think there's a constraint for Christianity based on all those questions. But sort of a fun thing to give.
Yeah.
A fun takeaway from that is that if we're going to play with the space, time, energy, and matter, those are our constraints.
Yeah.
That's not the constraint of God. That's my opinion. Okay.
Yeah. What may happen if we find out those aren't our constraints as much as we think they are?
Yeah. Well, and so kind of a fun way to play with the constraint, just very briefly, is that if we see each other, we see images of each other. So there's light falls upon us, and it's the light that's reflected, and the interaction of the material with the light that gives the red shirt, the green shirt, the black and white, the face, the hair, everything like that. So that's an image that comes at us. And a fun play on this is that 2,000 years ago, Jesus was walking the road to Emmaus, and two believers were walking, they didn't recognize him. That light of that day of the rotation of the earth, that place in space, an image of God, of Jesus, God, was reflected and went out in space. Light travels at the speed of light. So make a real big telescope, go 2,000 light years every year, how far light travels away from Earth, and you'll still see Jesus walking.
Yep, it's true. It's true. Looking light years away is like looking back in time. It's crazy. Cool. What else do we hear? Anything else cool, silly at our conversations at our tables? At ours, we talked a little bit about this, the third question, and a lot about the soul. Like, what is the essence of a soul? And the image of God, how are those related? Can we find souls or image of God in other people? Like, how would we be able to locate, say, if it was on Earth or in another distant land, whether this other creature has the image of God the same way that we think we do? I don't know how you do that. Anything else? Yeah, go to Cindy.
We started to play just a little bit with the idea of heaven just being another dimension, and so just that idea that we step into another dimension, and we just started playing with that.
Oh, that's really cool. Heaven is another dimension parallel to ours. Ooh, yeah. It's at
hell,
hand. It's right here. It's so close, so you just can't see it. Oh, that's so cool to think about. Oh, everyone. Yeah, okay, go one more to there, and then I'll wrap us up, because we're past time, I know.
We also talked about the second one and sort of related that to climate change. And we know that it's going on, but it's going on so slowly that a lot of people don't believe it. don't think it's happening or it's not happening fast enough or somehow.
Yeah.
And that's the realm we're stuck in now. So.
Interesting. Thanks. Thank you. Man, I have had so much fun with this. I've had a blast with this class. Thank you all for coming with me. Thank you for just like trying this crazy thing. This is a really kind of silly, ambitious class to try to teach, especially when I am not a scientist nor a physicist. But thank you. Thank you so much for coming. And we have scientists and science teachers and things around the room. Talk to them. Don't talk to me if you have questions, because I don't know what I'm talking about. But really, really, I hope that this class has made you go, I hope it has opened doorways to new ways of seeing the world. And I hope that today has been wonderful. So thank you.
Thank you, Kyle.